Okay. All right. So just as a reminder, this training will be recorded today. So, hi everybody. I am Mariana. I'm the Safety and Compliance Officer here at USF, and welcome to the Biosafety Core course. So, this course is required for anybody who is listed on a PI's IBC protocol that involves the use of recombinant DNA or infectious agents. Once we complete this training, there is a post-assessment quiz that needs to be completed, and that is how you will receive credit for today's training. Once you complete the quiz and you receive your certificate, the training is valid for 3 years. Once your training is close to expiring, you are going to receive a little notification from the ARC system. So the ARC system will start kind of sending you some emails, just letting you know that your training is expiring soon. And there is a few ways that you can renew your training. So you can either join us on Teams again, retake this training with us. You can also do the pre-recorded version of this training. And then we also have other trainings such as trainings for working with viral vectors, centrifuges, trainings about, disinfectants and things like that. So you do have a little bit, more options when it comes to renewing your training in 3 years. Just to give you a little bit of an introduction, there are 3 of us here in the Biosafety office. So there is Debbie Howarth, who is the Institutional Biosafety Officer, as well as the Biosafety Manager. There is myself, who is the Safety and Compliance Officer. So I do this training and I do a lot of the laboratory inspections as well. And then we also have Jamie Cordery, who you will get a lot of emails from when it comes to the training. So she is the one who processes the trainings and does the emailing back and forth for people who have training questions. So this is the list of all the topics we are going to cover today. So there are quite a few. And we're first going to start out by providing you with a general overview of the principles of biosafety, including what is a laboratory-acquired infection and a risk assessment. And please don't mind me if I pause. I'm just letting people in that are joining us. Okay. We're also going to go over the biocontainment levels, including the PPE that needs to be worn in the laboratory and the equipment that are going to be used. And then we'll cover our decontamination, spill, and exposure responses. And then lastly, we'll be provided with a brief overview of the NIH guidelines for research involving recombinant DNA, the Institutional Biosafety Committee, the CDC and USDA select agents and toxins, and the shipping of infectious and regulated materials. The first topic today that we're going to cover is the principles of biosafety. Biosafety is a safe handling and containment of biohazardous materials to avoid accidental exposure or release into the environment. This is achieved through administrative controls, engineering controls, personal protective equipment, and the practices and procedures put in place in the laboratory. The main purpose of biosafety is to ensure the safety of people, including researchers in the community, the environment, and the product being worked with. So first and foremost, we want to protect personnel working in the lab spaces, as well as anyone entering the facility who does not work in the lab, such as maintenance workers, equipment technicians, and janitorial staff. We also want to protect the environment by preventing any release or exposure of infectious agents being manipulated in the lab.
That's the Clint cards that Kathy's waiting for.
And then the goal is to keep your organisms contained within the laboratories. And then finally, we want to protect your product. So we want to work to maintain the integrity of your research and ensure the validity of your test results. A biohazard is an agent of biological origin that has the ability to cause disease in humans. It poses a hazard to the health of the individual working with that agent, other people around them, the community, and the environment. Biohazards include replication deficient viral vectors that are commonly used in research, infectious microorganisms such as bacteria, yeast, and parasites, and uncharacterized human clinical samples. A major concern when working with infectious agents is the possibility of someone becoming infected with the organism they are working with. This is called a laboratory acquired infection, or an LAI. An LAI is an infection that is obtained through laboratory or laboratory-related activities as a result of work with infectious biological agents, regardless of whether there are symptoms. When it comes to the occurrence of LAIs, 80% that have occurred have had unknown or unrecognized causes, meaning it was not able to be determined how that person became infected. Out of the 20% of LAIs where the cause was able to be determined, 80% are caused by human error and 20% are caused by equipment failure. Therefore, it's very important to make sure that you are trained in the procedures you will be doing and that you have a good understanding of what you will be doing as well as what you will be working with. The top 4 accidents that result in an infection are spills and splashes, accidentally penetrating the skin with dirty needles and syringes, the mishandling of sharp objects such as broken glass, and getting a bite or scratch from an infected animal. So this slide here just shows some examples of LAIs that have been documented. And the main thing to grasp is that it's very important to know the signs and symptoms caused by being infected with any of the agents that you or others in your area are working with. It's also extremely important to make sure that you report any potential exposure or if you happen to become ill after working with any of these agents. It's important to follow safe lab practices and protect yourself and others. There are several ways that you can potentially infect yourself or others when working in the lab. They can be mitigated by keeping your personal items outside of the laboratory to avoid contamination. And you always want to assume that your gloves are contaminated. Therefore, it's best to avoid touching any of your personal items, such as your cell phone, with your gloves. You always want to keep a designated set of supplies within the laboratory, such as pens, pencils, notebooks, and calculators. And be sure these supplies remain inside of the laboratory and that they are only used for lab work. And then you want to avoid activities in the lab that may cause you to become infected with the organisms that you are working with, such as eating, drinking, touching your eyes or mouth, and applying cosmetics. And then lastly, the most important thing that you can do to protect yourself is wash your hands regularly. This should be done after removing your gloves and before every time you leave the lab. Our goal is to minimize the risk of an LAI occurring as much as possible. How can we do this? The number one thing we can do is a risk assessment of the work you are doing and the agents you are working with. You also want to make sure that you have SOPs in place and that you follow them. Consider if there are immunizations available against the organisms that you are working with. You want to have your proper education and training and use the appropriate precautions when working in the laboratory. You want to know the signs and symptoms of the organisms that you're working with if you were to become infected, and you want to report any injury, accident, illness, or potential exposure to ensure you receive proper treatment. A biological risk assessment is a process used to identify, evaluate, and control risks associated with biological agents in laboratory settings. The purpose and primary goal of a biological risk assessment is to minimize risks and create a safe working environment for individuals working with biological materials. The first step in the risk assessment process is to identify the hazards and risks. So, first, you need to understand the nature of the work being performed, including identifying the specific biological agents involved and looking at the processes, procedures, and tasks related to the work. Next, the risks need to be evaluated. This involves assessing the likelihood of an exposure or injury occurring. Then evaluate the consequences if such incidents were to happen, and what are the existing control measures and their effectiveness. Lastly, you want to implement risk mitigation plans. These plans are strategies to reduce or eliminate the risks. They include the necessary control measures, such as PPE and/or containment practices needed to be put in place, and a determination of the appropriate biosafety level for the proposed work must be done. So, when we perform a risk assessment, there are some criteria that we have to follow. First, we're going to look at the agent and take into consideration the characteristics of that agent. We're going to look at the pathogenicity of the organism, meaning how easily it spreads from person to person, its route of transmission, and its host. So, what type of host it infects and how that infection occurs. We will also take into consideration if there are vaccines or treatments available for the organism that you're working with. Then we look at other factors, such as the organism's stability in the environment, the infectious dose, and the concentrations that you will be working with. Then we look at several factors that can affect an individual's ability to fight off infections. Children and elderly individuals are more prone to infections. Certain medications, such as corticosteroids, can suppress the immune system, while malnutrition can weaken the body's defenses. Pregnant individuals experience changes in their immune system, and some infections can harm the fetus. And conditions like diabetes or cancer can impact immune function. So, looking at all these factors will help determine how we can safely work with these agents. The National Institute of Health has characterized biological agents into 4 risk groups based on their potential impact on healthy human adults. These risk groups help assess the hazards associated with handling such agents. The risk group 1 agents are not known to cause any disease in healthy adult humans. They pose minimal risk and are generally safe to handle. Examples of such agents include non-pathogenic bacteria and viruses. Risk group 2 agents, and plasmids. Risk group 2 agents are associated with disease, but the illness is rarely serious. Preventative measures or therapeutics are often available. Examples of such agents include common pathogens like E. coli, influenza virus, and Staph aureus. Risk group 3 agents are associated with serious or lethal human disease. Preventative measures or therapeutics may be available but are not always effective. Examples of such agents include Yersinia pestis, HIV, brucella, and TB. And then lastly, our risk group 4 agents are highly dangerous and can cause severe, often fatal diseases. No effective treatments or preventative measures exist. Examples of such agents include Ebola virus and other deadly pathogens. The route of exposure refers to how an infectious agent enters a person's body, and the route of transmission refers to how a disease is spread from one host to another. Some of the common routes of exposure and transmission for infectious agents include ingestion, splashes in the eyes, absorption through the skin, needle sticks or punctures, and the inhalation of aerosolized material. Knowing these routes is crucial for implementing effective control measures to minimize or prevent exposure or transmission. Breaking the chain of infection involves interrupting the transmission of infectious agents at various points in their cycle. The chain of infection consists of six links, and breaking any one of these links can help prevent the spread of disease. There are places where procedures or PPE may be put in place to break the chain. The portal of entry is where the infectious agent enters a new host, such as through broken skin, the mucous membranes, or inhalation. So we want to break the chain right here um, by ensuring that nothing infects one of the laboratory workers. This can be accomplished through the use of PPE, hand washing, and proper wound care. So now we're going to take a look at the biosafety containment levels for a laboratory. Biosafety containment levels play a critical role in ensuring the safe handling of infectious agents in laboratory settings. Containment pertains to the methods, facilities, and equipment employed for managing a particular biological agent. The primary objective of biosafety levels is to reduce or eliminate exposure to hazardous biological substances. Each level corresponds to specific practices, equipment, and facility design aimed at controlling and mitigating risks. Biosafety levels are progressive in nature, with each level building upon the previous one. As we progress from BSL1, which is the lowest level, to BSL4, which is the highest level, the requirements become more stringent. The components of the biosafety levels include laboratory practices and techniques, safety equipment, such as our primary barriers, and facility design and construction, which is our secondary barriers. The laboratory practices and techniques involve following protocols to minimize splashes, aerosols, and accidental exposures when handling pathogens. Safety equipment needed for the primary barrier includes biosafety cabinets, which provide a controlled environment for handling pathogens, and safety centrifuges that have sealed rotors or cups for safe sample processing. Personal protective equipment like gloves, lab coats, goggles, and face shields are essential for researchers. Facility design and construction for the secondary barrier include ventilation systems that are critical for maintaining air quality and preventing contamination. The placement of sinks, eye wash stations, and showers is important for layout and location. Restricted access is also necessary, especially in high containment facilities. The biosafety levels are used to categorize infectious agents and toxins based on their risk level. So there's 4 levels of biosafety, each with different requirements and safety procedures. Biosafety level 1 is used for studying infectious agents or toxins that do not consistently cause disease in healthy adults. Basic safety procedures are followed, and no special equipment or design features are required. Biosafety level 2 is used for studying moderate risk infectious agents or toxins. These agents pose a risk if accidentally inhaled, swallowed, or exposed to the skin. Biosafety level 3 is used for handling high risk infectious agents that can cause serious diseases and have the potential for aerosol transmission. And then lastly, biosafety level 4 is the highest level in containment and is used for studying extremely dangerous pathogens. So the risk group serves as a starting point in determining the appropriate biosafety level for handling infectious materials. And then depending on the specific experiment or situation, the precautions can be increased or decreased. So, for example, when I was working in an animal disease diagnostic lab, we were testing animal tissues for the presence of the triple E virus. But since we were not working with the actual virus or culturing the virus, we were able to do our diagnostic testing in our BSL2 lab instead of our BSL3 laboratory. So this is our BSL1 laboratory, which is the lowest level of containment, and it's a very standard laboratory space. It is generally where standard microbiology and molecular biology work is going to be conducted. So in a biosafety level 1 lab, our standard practices are designed to ensure a safe working environment when handling low risk microbes. Policies to control access to the lab must be implemented. Personnel must wash their hands after handling potentially infectious or hazardous materials and before leaving the laboratory. Eating, drinking, smoking, and storing food for human consumption are not allowed in the lab. Also, the handling of contact lenses and applying cosmetics is not allowed. Mouth pipetting is prohibited, and mechanical pipetting devices must be used. Policies for the safe handling of sharps, such as needles and broken glassware, must be developed and implemented. And procedures should be designed to minimize the creation of splashes or aerosols. Work surfaces must be decontaminated daily and after any spills, and all waste must be properly disposed of according to institutional guidelines. And then lastly, you don't want to handle broken glassware directly. You always want to use a mechanical means, such as a brush with it or a broom with a dustpan or tongs or forceps to pick up any broken glass. I don't know if anybody here has experienced mouth pipetting, but feel free to raise your hand if you do. I definitely don't, but I know that's not a common practice anymore, thankfully. In a biosafety level 1 lab, the personal protective equipment is designed to protect individuals from lowest microbes that pose little to no threat of infection in healthy humans. So you'll need a standard laboratory coat or gown to protect your clothing and skin from any spills, disposable gloves to protect your hands, safety glasses or goggles, especially if there's a risk of splashes, and then you need closed-toed shoes to protect your feet from spills or dropped objects. Secondary barriers are minimal since the work involves low risk microbes that pose little to no threat to healthy humans. The primary focus is on good microbiological practices. The laboratory should be separated from public areas to prevent unauthorized access. A sink for hand washing is required to ensure proper hygiene. Surfaces should be easily cleanable to maintain a sanitary environment. This means the bench tops must be impervious to water and the chairs must be covered with non-porous material. So there can't be any fabric covered chairs within the laboratory. So we're now going to add an additional layer of containment and transition from a BSL-1 to a BSL-2 laboratory. This laboratory involves enhancements to practices and containment measures. So here are the key features of a BSL-2 facility. The lab must have controlled access to prevent unauthorized entry. Some laboratories have this by having locks on their doors, or you have to have key card access to allow you to a certain floor or area that contains the BSL-2 laboratories. There also need to be sinks available for hand washing, which are typically near the exit. Eye wash stations must be present in case of accidental exposure. An autoclave for decontaminating waste materials is required. And Class 2 biosafety cabinets are used for procedures that may generate aerosols or involve infectious materials. All work surfaces and floors should be easily cleanable to maintain hygiene, and there should be lab furniture covered with non-porous material. You also want to make sure that there's no carpet anywhere on the laboratory floor. And proper ventilation systems need to be available in order to ensure air flows from clean to contaminated areas, reducing the risk of airborne transmission. And then lastly, the vacuum lines need to be protected. The BSL-2 laboratory has the same special practices as the BSL-1, but with some additions. So all personnel working in the laboratory must complete their required training. So this includes the training provided by our office, such as the training that we're doing today, as well as any training that is provided by the PI or lab manager. A biosafety sign must be posted at the laboratory entrance to communicate any potential hazards that are present. A durable leak-proof secondary container must be used when transporting any virus, bacteria, or other infectious agents around the laboratory or to other locations, such as the core facility or the vivarium. And so here pictured is your secondary container. And so as you can see, it's a plastic container. So if you drop it, it's not going to break open. And the lid to it is clipped to the bottom. So if you drop it, the lid's not going to fall off. And then you can't do a good seal. So if for some reason, the tubes inside the secondary container break, whatever culture is inside those tubes is not going to leak outside of that secondary container. The biosafety manual must be available in the laboratory and include laboratory-specific standard operating procedures. Your equipment should be routinely decontaminated with an approved disinfectant effective against the agents that you're working with. And additionally, the equipment must be decontaminated following a spill inside the containment, or if the equipment will be repaired, maintenance, or removed from the laboratory. If immunizations are available against the agents being worked with, they should be offered to personnel. And any spills, accidents, or incidents that may result in an exposure must be reported. And then lastly, culture stocks and other potentially infectious materials must be decontaminated before disposal. The handling of sharps requires strict precautions to prevent injuries and potential exposure to infectious agents. You want to immediately discard used disposable sharps in puncture-resistant, leak-proof containers that are clearly labeled with a biohazard symbol. These containers should only be filled to the 3/4 line, and you never want to bend, shear, break, recap, or remove needles from disposable syringes by hand before disposal. And whenever possible, you always want to substitute plastic for glass. And always consider the use of safer sharps, such as syringes that resheath the needle, needleless systems, and other safety devices to minimize the risk of needle stick injuries. The laboratory supervisor should have ample experience with the agents being handled and should provide specific training to the personnel for handling these agents. Training should also be given regarding personnel's duties, potential hazards, and necessary precautions to prevent exposures. And access should be restricted to the laboratory to personnel only. Laboratory personnel should be aware of the potential hazards present in the lab and from the agents being worked with. You also want to ensure that you're trained and proficient in the techniques that you'll be performing in the laboratory, and you want to report any incident that may result in an exposure to ensure that you receive the appropriate treatment. For your PPE, you want to wear a long sleeve lab coat at all times to protect your clothing and skin from spills and splashes. The lab coat should be buttoned and the sleeves should not be rolled up. You want to have your disposable gloves, which are mandatory to protect your hands from exposure to infectious materials. And safety glasses or goggles are required to protect your eyes from splashes or aerosols. In some cases, face shields or surgical masks may also be used for additional protection. To protect your feet from spills or dropped objects, closed-toed shoes are mandatory, and additionally, long pants must be worn to protect your legs. So the person in this picture to the left is appropriately dressed for working in a laboratory. As you can see, majority of their skin here is covered and protected. They're wearing all of their required PPE. They also have on their eye protection. to protect their eyes from any splashes. And a really important one that we haven't talked about is their hair is pulled back away from their face in a ponytail so it will not fall into any of the work that they're doing. BSL-2 containment is needed for the use of biological toxins. Specific requirements for their use are provided in the CDC Biosafety and microbiological and biomedical laboratories. So in short, that's the BMBL. You need to have an inventory that is kept with the toxin under lock and key. A chemical hygiene plan specific for the toxin in use must also be developed for your laboratory. So unlike infectious agents, the inactivation of toxins can vary by each toxin. And so you want to ensure that the toxin you are working with is appropriately inactivated. The plan must include a description of the containment, such as, are you going to be using fume hoods or biosafety cabinets? It also should contain the PPE that will be worn by the staff and the spill management, exposure, and accident responses. When toxins are in use, a sign must be posted outside of the laboratory that reads toxins in use, authorized personnel only. This is something that we do create for the laboratories working with toxins, and we will bring it to your lab when we come to do our BSL-2 inspections. Some toxins are select agents and require registration with the CDC, unless the amount of the toxin does not exceed at any time an amount set by the CDC select agent program. So to address the concern that someone might stockpile toxins by receiving multiple orders um, below the excluded amount, the CDC has a toxin due diligence provision. So this requires a person transferring toxins and amounts which would otherwise be excluded from the provisions to use due diligence to assure that the recipient has a legitimate need to handle or use such toxins. They must also report to the Federal Select Agent Program if they detect a known or suspected violation of federal law or become aware of suspicious activity related to the toxin. The transferring of select agent toxins will require the USF Select Agent Toxin Due Diligence form to be completed to record the transfer. And the form requires information for both the transferor and transferee. So we're now going to discuss the BSL-3 laboratory, which are designed to contain agents that have an exposure risk via inhalation. These laboratories have extra precautions in place to prevent the aerosol transmission. Some of these include an anteroom for donning PPE, and there is a pass-through autoclave, as all waste leaving the BSL-3 needs to first be autoclaved to ensure that there are no viable infectious agents in the waste. BSL-3 facilities are either located in a separate building or in an isolated zone. They have double door entry, which is typically through a set of interlocking doors. There is directional inward airflow. They have single pass air, which is HEPA filtered to the outside. There are enclosures for aerosol generating equipment, such as like a tissue homogenizer. The room penetrations are sealed. The walls, floors, and ceilings are water resistant for easy cleaning and disinfecting. And then lastly, there's a hands-free sink for hand washing. So due to the potential for the spread by aerosol transmission and the potentially infectious aerosols, we need to protect our respiratory systems when working in a BSL-3. So all manipulations involving infectious materials must be performed within a biosafety cabinet. Additionally, respiratory protection is worn. This must be an N95 mask or a powered air purifying respirator or a PAPR. N95 masks must be fitted to your face and requires annual testing to assure an appropriate fit and protection. I always fail the fit test, so I can never wear an N95 mask. And then the PAPR you wear with a hood that goes over your head and it supplies you with purified air. PAPR is actually nice. It's like an air conditioning over your head. Supervisors must have experience working with the agents being used. They also must restrict access to the laboratory and establish criteria for entry. Policies and procedures for working with the laboratory must be developed, and then they must ensure that all personnel receive their appropriate training. Laboratory personnel responsible for making themselves aware of the potential hazards that are present, and guidelines must be strictly adhered to. They must ensure that they are trained and proficient in the techniques that they will be performing, and any incidents that occur must be reported. And then some laboratories do require that personnel participate in a medical surveillance. So lastly is our BSL-4 lab. This lab is for working with high-risk agents with the potential exposure to pathogens spread by aerosol or the unknown mode of transmission. There are no BSL-4 containment laboratories at USF, and work with agents that require BSL-4 containment is not permitted on USF campus. So now we're just going to dive a little deeper into some special practices that we feel require a little bit more attention. So when working in a BSL-2 laboratory or higher, the biohazard symbol needs to be posted on your door signage and equipment. So this symbol, it's a universal symbol, and it communicates that there is a potential risk present due to infectious agents being stored or used within the laboratory space. Any laboratory equipment that is used for working with or storing infectious agents, including your biohazardous waste containers, must be clearly marked or labeled with this symbol. And then a biohazard sign is essential for communicating the presence of biological hazards in the laboratory. So all laboratories of BSL-2 or higher must have a biohazard sign on all entrances to the laboratory space. And the information that must be present on the sign is the biohazard symbol, as well as the biosafety level of the laboratory. It also needs to include the PI's name and contact information, the biological agents that are being used or stored within the laboratory, the emergency contact information, the required PPE, and if applicable, any immunizations that may be required. And again, this is a sign that our office does create for you and bring to your laboratory for you to post up when we come to do our BSL-2 inspections of your laboratory space. So gloves should be selected based on the task that you will be performing. And then you always want to check your gloves for tears before you begin work. And remember to also check them periodically for tears when performing laboratory work. This basically just ensures protection for both you and your experiments. I can't even begin to tell you how many times I would put on a fresh pair of nitrile gloves. I would sit down at my biosafety cabinet and I would start either, passaging some cells or setting up some experiments. And I would look down and the finger portion of my glove would be missing. And I would be, really nervous for like the next week because I would be afraid that my cells were contaminated and my experiment was ruined. So, it does benefit you to just check your gloves every once in a while. I don't know if that's happened to anybody else, but it's happened to me many, many times. Gloves should never be washed or reused. And then you want to remember to change your gloves often when you're working with infectious agents. Some tasks may require the use of double gloves, and that's perfectly fine. And then you always want to consider gloves worn in the lab to be potentially contaminated. So you want to avoid touching your face, your phone, or other personal items, while you're wearing your gloves. And then you always want to remove your gloves before leaving the laboratory. And you want to use the clean hand, dirty hand technique for glove removal. So when using the clean hands, dirty hands technique to remove your PPE, you're operating under the idea that your PPE has a contaminated side and a clean side. And so the area that's contaminated is going to be the outside or the outward facing part of your PPE. And so this is the part of your PPE that is facing towards or in direct contact with your workspace, or the agents you're working with. So these contaminated areas pose a risk of transmitting pathogens. The clean area is the inside or the inward facing portion of your PPE. And this is the part of your PPE that is facing away from your workspace and agents. And it's going to be in direct contact with your skin or your clothes. And your clean areas are safe and can be touched without the risk of contamination. So, knowing how to properly remove your gloves is very important. Your gloves are potentially contaminated, and you want to remove the gloves while ensuring safety and preventing contamination. So, we have a video that demonstrates how to remove your gloves using the clean hands, dirty hand technique. And I just want to make sure because I had the volume low on my computer because I kept getting notifications. Did everybody hear the entire video or just like the second half?
I heard the whole thing.
Okay, perfect. Thank you. I appreciate it. Thanks, everyone. All right, so once we remove our gloves, we have to wash our hands. So, hand washing is crucial practice for maintaining good hygiene and preventing the spread of germs. When working in a laboratory, you should always wash your hands after removing your gloves and right before leaving the lab. So, hand washing should be performed for a minimum of 20 seconds, and that's approximately the time that it takes to sing your ABCs or sing happy birthday twice. So, let's see how long 20 seconds really is. And let's see if I can get this to work. Yeah. Okay. So, as you can see, 20 seconds is actually longer than we think. So, all righty. Okay. And so here we just have a fun video from a hospital in England, and they're demonstrating how to wash your hands visually, showing that you need to effectively scrub all areas of your hands. This is my favorite part of the training. I hope all of you really enjoy the video. All right. Well, I hope you all enjoyed the video because, again, that's my favorite part of the training. So when it comes to your vacuum lines, protected vacuum lines are essential to prevent contamination and exposure. In a BSL-2 lab, this can be accomplished either using a liquid disinfectant trap or an inline HEPA filter. So, liquid disinfectant traps are used to capture any liquid that might be aspirated during procedures. This would contain a volume of bleach to ensure that when full, the concentration of bleach is 10% to neutralize any biohazardous material. HEPA filters are installed in line to capture any aerosols or particulates that might be drawn into the vacuum system. These filters, they're crucial for preventing contamination of the vacuum pump and the environment. And then in a BSL-3 laboratory, only an inline HEPA filter can be used to protect your vacuum lines. To minimize the risk of exposure to hazardous substances, it's essential to follow these safety measures when using a centrifuge. You always want to ensure that safety caps and sealed rotors are used during centrifugation to prevent any spillage or leakage of hazardous materials. And then you want to load and unload samples inside the biosafety cabinet to contain any potential aerosols or splashes, thus reducing the risk of exposure. It's important to regularly inspect the centrifuge O-rings for signs of wear, cracks, or absence. If any of these issues are detected, promptly replace the O-rings to maintain the integrity of the centrifuge and prevent any potential leaks or exposure to hazardous substances such as aerosols. And so the O-ring is this black ring right here that's going around the centrifuge bucket. All right, so we've made it like halfway through the training. So if everyone's okay with it, I'm just going to give you about a 5-minute break so everyone can kind of grab something to drink, get up and stretch a little bit, and we will come back and finish the second half of the training at 2:55. All right, everyone. So it's 2:55. So we're just going to go ahead and begin the second half of our training. Just as a reminder, again, the training today is being recorded. And so we are now going to discuss biological safety cabinets, which are also commonly referred to as BSCs. So a BSC is a containment device that's used when working with biological agents. And its primary purpose is to protect the lab personnel worker and the environment from viable organisms. A BSC uses airflow to provide containment when performing procedures with infectious agents that have the potential to produce splashes or aerosols, and if you're going to be working with large volumes or high concentrations. HEPA filters are an important component of BSCs. They filter the air that's circulating through the cabinet before it's released into the environment. These filters are not going to trap chemicals, fumes, or vapors, and they're designed to trap particulates as small as 0.3 micrometers in size, which is the most penetrating inhalant particle size. There are several types of BSCs available on the market. So, our Class 1 BSCs provide personnel and environmental protection. The exhausted air is HEPA filtered before being released into the environment. The most commonly used BSCs are Class 2 cabinets. They provide personnel, environmental, and product protection. So both the exhaust and intake air are HEPA filtered. The intake air being HEPA filtered is what creates that sterile working area, which is suitable for working with aerosol transmissible microorganisms, viruses, and tissue culture. And then lastly, we have our Class 3 BSCs, which provide maximum protection for the environment and the worker. These cabinets are gas tight and suitable for work involving BSL-4 agents. So BSCs are designed with a directional airflow within the cabinet. The laminar airflow that's created across the opening of the cabinet helps to contain the aerosols and to prevent contamination. So here's a video that we have of somebody using a smoke maker to demonstrate this airflow within the cabinet and how turbulence within the air can disrupt that airflow. So as you can see with the previous video, when it comes to turbulence in the air, it is really important to consider the location of your BSC and where to put it in your laboratory in order to ensure its effectiveness. So you want your cabinet isolated from other work areas and located away from places in the lab where air turbulence can be present, such as, high traffic areas, airflow ducts and laboratory doors, because even just the opening and closing of your laboratory doors can create that air turbulence. And then to ensure that your cabinet is functioning correctly and providing protection, they must be certified annually when they're moved to a new location. So this could be, another lab or a new location within the same laboratory, and when the HEPA filter is changed. So when it comes to working in a cabinet, how many of you by show of hands have experience working in a BSC? All right. I think I'm seeing a few hands go up here. I see one in the chat. All right. Well, this slide here just shows how to properly work in a biosafety cabinet. And it seems like a lot of you know how to do that. So I just want to kind of touch on some really important things on this slide. You always want to prepare and preload your supplies that are needed for the work you're going to be performing in your cabinet before you actually sit down to do your work. Additionally, you always want to make sure that your airflow grills in the front of your cabinet, as well as in your back of the cabinet, are not blocked to allow proper airflow. I know a lot of people will follow like calculations or an SOP. So something that I used to do instead of, putting my SOP or calculations on the grill in the front of the cabinet, I used to use like a magnet to hold it up above the opening of the cabinet. When you have completed your work, you want to decontaminate all of your items before removing them from your cabinet. And then once you have emptied your cabinet, removed everything from there, you then want to use an approved disinfectant for decontaminating your cabinet. It is also worth noting that UV light should not be the primary method for decontaminating your BSC. So you do always want to use that chemical disinfectant as well. So we never want to use open flames inside of a biosafety cabinet. Big no-no. This actually cost me to fail my first interview question outside of college. So I had a professor that taught me how to use an open flame inside of a BSc, even though it was incorrect practices. And this was one of my first questions in my first interview upon graduation, and they looked at me like I had four heads. So an open flame inside of a BSC creates turbulence that disrupts the pattern of the filtered air being supplied to the work surface, which can cause a breach in containment. Additionally, the heat can damage the HEPA filter. There are alternatives that can be used. So you do have a flame on demand that you can use if you do need a flame. There's also small electric furnaces that are available for decontaminating loops and needles. And then disposable or recyclable sterile loops should be used whenever possible. HEPA filters used in BSCs are not effective at capturing volatile or vaporized chemicals. So this means that the chemicals pass through the HEPA filters and potentially are recirculated into the laboratory environment, which is why you always want to use your fume hoods. These chemicals can also damage the HEPA filter in your biosafety cabinet. So many BSCs recirculate a significant portion of the filtered air within the cabinet. So this can lead to the accumulation of chemical vapors inside the BSC. And a buildup of flammable materials can lead to a fire or explosion, while toxic chemicals can pose health risks if they are recirculated. You can use a small quantity of hazardous chemicals in a hard duct class 2 type B cabinet. Okay, so now that we've thoroughly covered how to properly and safely work in a laboratory setting, take a look at the picture displayed on the slide and feel free to either take your mics off of mute or put it in the chat. Just let me know if you can identify any hazards or unsafe work practices within this photo. Yes, the rolled up sleeves. Thank you. Not wearing gloves. Not wearing gloves while handling contaminated objects. Yes, very true. Yep, there's a coffee cup in the laboratory. Yes, there is spilled something everywhere. Yes, the pipette tip out of the hood, and it looks like it might be touching their pants as well. So someone actually pointed that one out recently. I didn't even notice that. Yep, the open petri dish, and it looks like something funky is growing in there too. So it's definitely not an empty open petri dish. Yep, the coffee cup on the bench. Yes, good eyes. This one I never noticed either. Someone had to point this out. The tube rack, it's blocking it looks like it's blocking the grills for the BSC. All right, great job, everybody. So it also looked like this person doesn't have their lab coat unbuttoned, or their lab coat is unbuttoned. They're touching their earbuds with their hands. So they need to clean up the centrifuge. So yeah, there's a few things going on in here. Okay, and then here's a photo of a biosafety cabinet that is being improperly used for laboratory work. I'm sure this would cause your PIs to probably walk in your lab and then turn directly around. And so, just as a quick reminder, when you are working inside of a BSC, there should always be, as few items as possible in order to not disrupt the airflow. So you definitely don't want your cabinet cluttered like this. The front and rear grills should never be blocked. And then, you always want to have a designated clean side and dirty side to avoid contamination. So this whole cabinet looks like every side's the dirty side. Okay, so now that we've discussed how to work in your laboratories and the common safety equipment that's used, we're going to review our decontamination and our spill response. So first, we're just going to quickly go over the definitions of a few words that are often used interchangeably, but they do have very distinct meanings. So first, it's decontamination, which is the process of reducing the number of disease-producing microorganisms and rendering an object safe for handling. And so this can be accomplished one of two ways, either via disinfection or sterilization. So disinfection is the use of physical or chemical means to virtually eliminate all recognized pathogenic microorganisms, but not all microbial forms on inanimate objects. So it's going to kill off everything except those really hard to kill organisms like your bacterial endospores. And then we have sterilization, which is where we use physical or chemical means to destroy all microbial life, including large numbers of highly resistant bacterial spores. So sterilization is virtually going to eliminate everything. Our decontamination methods include heat, such as moist steam, dry oven, or incineration. We also have chemicals, which include our liquid chemicals, such as our bleach solutions. And then we also have gases or vapors, such as vaporized hydrogen peroxide. And then lastly, we have radiation, which consists of gamma and X-rays, as well as UV light. So infectious agents vary in their resistance to decontamination by chemicals. So it is really important for you to know where your agent falls on the scale. The most resistant being bacterial spores. They are very resistant to chemicals. These spores are produced by bacteria specifically for the purpose of allowing bacteria to survive harsh environments. Whereas lipid viruses are the least resistant to, these chemical disinfectants. And it's important to ensure that the chemical that you are using is effective against the organisms that you are working with. So hypochlorite solutions or household bleach is the most common disinfectant used in laboratories. It's inexpensive and it's effective against most agents. Generally, it's used at a 10% solution for small spills and general disinfection. It can also be used undiluted from the bottle for a large spill or if you're working with a high organic load. So to ensure efficacy, 10% bleach should be made fresh at least weekly and kept in an opaque bottle. There are many factors that can affect the efficacy of bleach. So these include the age of the solution, the concentration, its exposure to light, and the amount of organic matter present. So to make a 10% bleach solution, you would simply mix 1 part household bleach with 9 parts water. Laboratories must have a biological spill kit readily available where the infectious agents are being used. So these spill kits are different from the chemical spill kits that you have. They contain all the items that are needed to clean up a biological spill. So the items that we recommend you keep in your biological spill kit are your concentrated disinfectant, your absorbent materials such as paper towels, a spray bottle, your autoclavable biohazard bags, a sharp container, the PPE that's required for cleaning the spill, such as your gloves, goggles, and lab coats, and then lastly, tongs or forceps for cleaning up broken glass. And although majority of these items are available in your lab, the spill kit does make it easy to quickly collect the items you need to clean the spill and protect yourself. So here are the steps involved in cleaning up a biological spill. And we do provide you with a copy of the biological spill response when we come to inspect your lab. So when we do provide you with this, you just want to post it somewhere in the lab where it is visible, where people can easily refer to it, or you can even place it inside of your spill kit, which is what a lot of the laboratories do. So just to quickly review, if there does happen to be a spill, the first thing that you need to do is notify others in your area. And then you'll need to don on your PPE for cleaning the spill, such as your gloves, lab coats, and eye protection. You can see this person's got it on. And then the spill needs to be covered with an absorbent material, and you want to pour your disinfectant around the area. Once you've had a contact time of 20 minutes, you want to carefully pick up your spill items as well as any broken glass with container. And then you want to wipe down the area of the spill with fresh paper towels soaked in disinfectant. And then discard of all your materials in a biohazard bag. After removing your PPE, just remember to thoroughly wash your hands. If you do have a spill that occurs inside of a BSL-2 laboratory, there are additional steps that need to be followed. So after you notify others in your area of the spill, you will then need to leave the laboratory, close the door, and post a warning sign to prevent others from re-entering the lab. After 30 minutes have passed, you can then enter the lab and begin cleaning your spill. These 30 minutes just allow any aerosols that may have been produced to just settle. If you have a spill of a BSL-1 agent that occurs outside of your lab, or a spill outside, or I'm sorry, or a BSL-2 spill outside of primary containment, this needs to be reported to the PI or laboratory director and the institutional biosafety officer or the biosafety office at biosafety@usf.edu. When it comes to working in a laboratory, there is always the risk of an accident or exposure occurring. So, examples of potential exposures include punctures to your skin, such as a needle stick, a splash to your mucous membranes, breathing in aerosols, contact with an open wound, or being bitten or scratched by an infected animal. Examples of potential accidents include a BSL-2 or BSL-3 spill outside a containment, the theft or loss of an infectious agent or recombinant DNA material, and the escape of an infected or transgenic animal. If you happen to have a potential exposure, you first need to wash the exposed site immediately for 10 minutes with copious amounts of water. Next, you want to remove any contaminated clothing. If you have a needle stick, cut, animal bite, or scratch, wash the area with soap and water and apply an appropriate disinfectant. For exposure to your mucous membranes, flush with water at the nearest faucet or eye wash station for at least 15 minutes. For skin contact, wash with soap and water and apply an appropriate disinfectant. And then next, you want to seek medical attention, no matter how insignificant the injury may seem. And you want to notify your PI or lab director as well as the biosafety officer as soon as possible. It is worth noting that some post-exposure treatments must be started within 1 to 2 hours of the exposure taking place. So it is important to notify your biosafety office, as soon as the exposure happens. All personnel must call 911 for medical emergencies. And the EH&S online USF injury, illness, and exposure reporting tool must be completed. And then lastly, the biosafety officer must be notified the same day as the potential exposure. For USF employees and volunteers, the supervisor must immediately contact workers' compensation and complete the supervisor's incident injury report and forward it to EH&S within 24 hours. And then the employer or volunteer must proceed to an approved medical care facility for an initial care and contact the Medical Health Administration office. USF students can go to the Student Health Services or to their personal insurance healthcare provider. And then Moffitt staff follow Moffitt Incidents website per Moffitt Work-Related Injury Policy EH13. If you are a PhD student that is doing research in a Moffitt laboratory, even though you are working in a Moffitt lab, you are still considered a USF student. So you would follow the USF student reporting. So this slide here just shows who to contact if you have a potential exposure while working in the lab based on your role at USF and if you are working in a laboratory for USF or Moffitt. So again, this sign is provided to you during our laboratory inspection. So it should be available and posted in your laboratory space for you to easily refer to. Whenever we receive a spill or exposure report, we do open up an investigation. And the primary purpose of the investigation is to determine the cause of the incident, make recommendations for corrective actions, promote safe practices in the laboratory, and to protect the researchers. It is worth noting that the investigation is not to assign blame to anyone for the incident that occurred. Our primary goal is to promote a safe working environment. So when reporting an incident to our office, please include a description of the incident, the organisms that were involved, the PPE worn at the time of the incident, the cause of the incident, such as the breach in protocol, and a solution to preventing similar incidents from occurring. And if for some reason, you don't provide all this information, we'll reach out to you and ask you to fill in the blanks. So if you are a volunteer, that just means that you're not classified as a paid employee and you're not a student working in a lab as part of a course requirement or to receive research credits. Before any volunteers can begin working in a laboratory, they do need to be approved through HR. If you are working with samples that may contain bloodborne pathogens, you want to report any potential exposures as quickly as possible to ensure that you do receive timely treatment. So please refer to this slide to make sure that you are reporting to the correct office. Near misses are incidents that did not result in an injury, but had the potential for an injury or illness to occur. It is beneficial to have these reported because it does help to identify risks before a person is injured or exposed to an organism. If you do have a near miss, please complete the USF incident and near miss reporting form just to document that you do recognize that there is a hazard and that a change in the lab was made to prevent that incident from occurring. So there was an incident that did occur with a USF employee where they went to the ER showing signs and symptoms of being infected with an agent they were working with in the lab. They knew not to take certain antibiotics because it would increase the risk of complications. The employee recovered and informed their supervisor that they had been sick and sought medical care. The USF Biosafety officer was informed of a possible laboratory acquired infection, and the employee followed up with the USF occupational health physician. Laboratory testing was performed, and it revealed that the employee was infected with the agent that they were working with. So it is important to report when there is a possible exposure. This does allow information to be exchanged between the treating physician and USF so that the employee can be treated for the specific agent and the appropriate diagnostic testing can be performed. Healthcare costs resulting from an exposure may also be covered by workers' comp. It helps to identify potential exposure hazards and it protects USF, the supervisor, and the employee. So next, we're going to talk about the role of the Institutional Biosafety Committee. So the Institutional Biosafety Committee, or the IBC, is established under the NIH guidelines. It plays a crucial role in ensuring safety and compliancy in research involving recombinant DNA at USF and its affiliated institutions. The IBC evaluates research projects that involve recombinant DNA to adhere to the NIH guidelines. The primary purpose of the IBC is to safeguard both people and the environment from biological hazards. By adhering to federal and state biosafety guidelines and directives, the IBC ensures responsible and safe research practices. The IBC provides oversight to the USF research community, and this is accomplished by performing a risk assessment of the projects involving infectious agents, recombinant DNA research, and select agents and toxins. If after review, the projects are determined to have all the appropriate safeguards in place, the projects are approved to begin their research. In addition to the reviewing of protocols, the IBC is also tasked with the review of noncompliances, spills, and exposures. They provide and develop recommendations on biosafety practices, operating policies, and procedures for the use of biohazardous materials at USF. All projects using infectious agents, recombinant DNA, or select agents and toxins must be submitted to the IBC electronically through Biosafety which is located on the ARC platform. For assistance with protocol creation and submission, please contact the Biosafety office at biosafety@usf.edu, and myself or Debbie will be more than happy to assist you. For any technical items related to ARC or Biosafety please contact the ARC Help Desk. So this would include situations such as I cannot log into my ARC account, or for some reason your protocols are not loading. So that would be issues that you would need to contact the ARC Help Desk for. And then if you would like more information about Biosafety you can find that on our webpage. All PIs and personnel must have an ARC account to submit and be listed on an IBC protocol. Please go to the ARC website to create your ARC account and then select study staff as your role. Once your ARC account has been requested, it'll usually be activated within 1 business day. All right, so we're now going to transition from the IBC to the NIH guidelines. And the NIH has established guidelines when laboratory work involves the use of recombinant or synthetic nucleic acids. They have established definitions for what they consider recombinant and synthetic nucleic acids, and these definitions are as follows. And I'm sorry, there's no way to shorten these. They are molecules that are constructed by joining nucleic acid molecules and can replicate in a living cell. They're nucleic acid molecules that are chemically or by means synthesized or amplified, including those that are chemically or otherwise modified but can base pair with naturally occurring nucleic acid molecules, or they're molecules that result from the replication of the previously described definitions. So the NIH guidelines cover practices related to recombinant nucleic acid molecules, synthetic nucleic acid molecules, and cells, organisms, and viruses that contain such molecules. These guidelines are not optional, so they are a mandatory condition for institutions receiving NIH funding, regardless of the funding source. So USF does receive funding from the NIH, and therefore all research at USF must adhere to these guidelines. Noncompliance can have serious consequences, including forfeiture of funding and suspension or limitation of financial assistance. The experiments that are covered by the NIH guidelines are the Section 3A experiments, which is the transfer of drug resistance. Approval from the NIH director and the IBC is required before starting this research. We have our Section 3B experiments, which is the cloning of toxin molecules. NIH OSP and IBC approval is required before starting this research. And we have our Section 3C experiments, which is the study of human gene therapy. Approval from the Institutional Review Board and the IBC is necessary before this research is started. The Section 3D experiments use infectious agents as vectors and use transgenic animals, and the Section 3E experiments use non-viral plasmids for gene expression. Both Sections 3D and 3E experiments require approval from the IBC prior to starting the research. And then lastly is our Section 3F experiments. These are exempt experiments, and IBC submission must be simultaneous with the project initiation, as USF requires registration of these projects. Viral vectors are commonly used in laboratories for work involving recombinant DNA. So BSL-2 practices and procedures must be followed when handling risk group 2 viral vectors, even if they are replication incompetent. There is a risk associated with the potential generation of competent viruses, the expression of inserted genes, and insertional mutagenesis. All right, so let's quickly discuss the regulations for the CDC select agents and toxins. So select agents are biological agents and toxins that have been determined to have the potential to pose a severe threat to public health and safety, to animal and plant health, or to animal or plant products. Part 42 CFR 73 implements the requirements for the possession, use, and transfer of select agents and toxins. So this slide shows the select agents and toxins that are regulated by the CDC. Some examples include the Ebola virus and monkeypox virus. These are the select agent and toxins regulated by the USDA that are specific to animals. Some examples are the avian influenza virus and the foot and mouth disease virus. And then this slide shows the plant pathogens that are regulated by the USDA. And then lastly, these are the overlap select agents and toxins that are subject to regulation by both the USDA and the CDC. So any laboratory that plans on using select agents and toxins must follow regulations implemented by Part 42 CFR 73. So these regulations include stringent record keeping of inventories of the agents, as well as who has access to the agents, individuals that have access to the areas where the agents are stored or used, and document transfer. The CDC or USDA must be notified if there is a loss, theft, or release of the select agent or toxin. The facility must have upgraded security. Overlap select agents and toxins must meet both HHS and USDA regulations. There are criminal penalties and civil money penalties for not adhering to these regulations, and additional training on select agents regulations is required. So lastly, we're just going to review the shipping of infectious regulated materials. The shipping of infectious and regulated substances is regulated by the DOT, IATA, DHHS, and DOC. The items regulated by these entities include substances that are infectious to humans or animals, recombinant DNA, biological toxins, diagnostic specimens, biological products, and dry ice. The shipping of hazardous materials requires appropriate documented training, which is provided by our office, and information about this training can be found on our website. Our training will teach you how to properly classify biological substances, package them for shipment, mark and label the packaging, and prepare proper documentation. If you will be shipping internationally, please contact export controls to ensure licensing requirements are followed. If you will be ordering infectious agents, an MTA may be required. So, an MTA is a signed document that is required for the transfer of biological materials between USF and a non USF organization. Vendors may require the PI to establish a customer account to purchase materials, and the institutional biosafety officer must review and sign the documents. The biosafety office will inspect the lab to ensure it meets the required containment for the materials, ensure all necessary approvals are in place, and assess and provide guidance on the biosafety risks of the agents being shipped. Biological materials shipped to or from USF may require a permit, and these agencies that may require permits are the CDC for imports into the US, the USDA for all imports and exports and interstate transports, and the US Department of Commerce for exports. So, in conclusion, biosafety is practicing safe science. It involves asking, planning, common sense, good lab practices, hazard communication, reducing risks to an acceptable level, and the concern for others and the environment. So, thank you everybody for joining us today for this training. I really appreciate you all being here. I am just going to copy and paste the links again in the chat. So here's the link to the updated PowerPoints. I am putting, here is the link to the quiz. And then please also give me some feedback, what you did like, what you didn't like about the training. Please give us some training feedback as well. Sorry, I just